Hello viewers, moving on to the next question in the series of GATE 220 electrical solutions from subject power electronics. The next question, question number 48 in the master question paper of GATE 220 electrical engineering from subject power electronics is also 2 marks MCQ type. It is from basically from converters, right? And the question is given as, in the following circuit the average voltage is V0 equal to V0 equal to 400 into 1 plus cos alpha by 3 volts. Right, and where alpha is the firing angle, as you all know, of this converter. If the power dissipated in the resistor is 64 watt, then the closest value of alpha in degrees is, and the options are given as A 35.9, B 46.4, C 41.4, and D 0. Let's move on to solution for this question. Solution calculation. Pretty simple, basic, fundamental. It is given power dissipated in the resistor. This resistor of 1 ohm is 64 watt. Power dissipated in the resistor, the average value of the voltage across the resistor is, say, VR. And the power dissipated across the resistor is VR square by R, which is VR square by 1 in this case, which is given as 64. So VR we get as what? Square root 64, that is 8 volts. Now since this is the average voltage, क्योंकि average voltage है, इंडक्टर क्योंकि एक कंजर्वेटिव एलिमेंट है, इसमें क्रॉस कोई पावर डिसिपेशन नहीं हो रहा है, एनर्जी इज कंजर्व्ड अक्रॉस द इंडक्टर, सो द एवरेज वोल्टेज अक्रॉस द इंडक्टर इज 0. तो इसके अक्रॉस एवरेज वोल्टेज अक्रॉस द इंडक्टर वी नीड नॉट कंसीडर. सो बेसिकली V0, द आउटपुट वोल्टेज इज द सम ऑफ दिस VR प्लस VL प्लस 500 volt. This voltage source. Now the average voltage across the inductor is 0 and average voltage across the resistance is 8 volt, already calculated. So 8 plus 500, that is 508 volts. Correct? सही है. Now this V0 value, the average voltage was given as in the form of alpha. The function of alpha is this. So you can equate this value with the one given. So what we get? 400 into 1 plus cos alpha by 3 equal to 508. So if you simplify it, this will cancel 1.27. So from here we get 1 plus cos alpha by 3 equal to 1.27. or cos alpha by 3 equal to 0.27, take 1 to that side, or cos alpha equal to 0.27 into 3, that is 0.81, right? So we get the firing angle alpha as cos inverse 0.81. We know that the value of cos inverse 0.8 is 36.87 or 36.9 like that. So as alpha cos theta is it decreases with the increase in theta, so cos inverse 0.81 will be slightly less than 36.7. that is among the options we can easily find out that it is 35.9, close to 35.9 degrees. Right, as cos inverse 0.8 is close to 36.79 degree, so cos inverse 8.81 is slightly less than that, 35.9. Other options are nowhere near, कहीं भी नजदीक नहीं है बाकी options. So the correct answer to the question is option A, 35.9, as the alpha is also in degrees per angle. So I hope the solution is clear. I approach this question with very basics. We first finding the using the power dissipated across the resistor to find the voltage across the average voltage across the resistor, right, which we have obtained as 8 volt. Next, the average voltage across the inductor is 0, as the inductor does not store any energy in every cycle. Next, the total the output voltage will be sum of inductor voltage, resistance voltage across resistance, and the 500 volt. So we get that as 508 volt. We equate it to the given value of the V0 given, and we find the value of alpha as 35.